Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about inverse proportion. In the previous video we talked about direct proportion, and we knew that two quantities were directly proportional to each other if as one quantity increased by a certain factor, so did the other, or as one quantity decreased by a certain factor, then so did the other. And the way that we set it up is that the ratio of one quantity to the other would be equal to the ratio in the same order of that one quantity to the other. So when we have a direct proportion, the two ratios are equal or the two quotients are equal. Now we're going to talk about inverse proportion. Two quantities are inversely proportional to each other if, as one quantity increases by a certain factor, the other decreases by that same factor. Or as one decreases by a certain factor, the other increases by that same factor. So they do the opposite. And when we have an inverse proportion, we know that the product of those two quantities will be constant. Here the ratio of the quantities was a constant, here the product is a constant. So that means that the product of the two quantities will equal the product of the two quantities. Let's take a look at some examples so you can understand what I'm talking about. So in our first example, if Leonard drives at an average speed of 100 kilometers an hour, it will take him 5 hours to reach a certain destination. How long will it take him if he drives at an average speed of 120 kilometers per hour? So Leonard's going to drive faster. It's not going to take him more time, so it's not a direct proportion. It's going to take him less time. If he were to drive at double the speed, it would take him half the time. So this is an inverse proportion, and we set it up as the products are equal. So we have 100 kilometers an hour times the time, 5 hours. And when we multiply that, what you'll notice is this just ends up being a distance. That distance should equal the same whether we drive at this speed or this speed. So 120 kilometers per hour times X hours. Now I just put the units in there so that you can see everything's consistent, but if you want, you can just set it up. 100 times 5 will equal 120 times X. So that putting the units in isn't necessary, but it just keeps you on track to make sure that your units are consistent for both quantities. When we solve for X here, we're just going to take 100 times 5 and divide by 120, and we get 4.17, and the time is in hours. Which makes sense. It's going to take less time driving at a faster speed. Let's take a look at some other examples. The next example says it takes 3 people a total of 4 hours to complete a task. How long does it take if there are only 2 people working? Now, this might not work out exactly because it depends if the rate of work stays the same, which it might not. But assuming that the rate of work stays constant, if we have fewer people working, it should take more time to do a certain job. Therefore, we know it's an inverse proportion. So we set it up as the two products are equal. So the products will be 3 people times 4 hours. And when we multiply that, it actually gives us the people hours to do the job. That will equal 2 people times the number of hours, which we don't know. Or in other words, 3 times 4 will equal 2x. 3 times 4 is 12. We divide by 2, so x will equal 6 hours. And that makes sense. We have fewer people working. It should take more time. That is an inverse proportion. Let's try some more. So this question says a gear with 15 teeth is in mesh with a gear having 35 teeth. If the smaller gear is turning at 1400 revolutions per minute, how fast is the larger gear turning? So I just made a rough diagram. We've got 2 gears in mesh. We know that this one's turning at 1400 revolutions per minute. We want to know how fast is that larger gear turning. The larger gear is going to turn slower because it won't even go through a full revolution when this gear goes through one revolution. When this gear goes through one revolution, this gear will only go through 15 teeth. So it's going to be turning slower. So because it's a larger gear, the speed will be less. Therefore, it's an inverse proportion. Therefore, we set it up making the products equal. So we have 15 teeth times 1400 revolutions per minute should be equal to 35 teeth times X revolutions per minute. I think it's easier if you look at it without units. We multiply 15 times 1400, we divide by 35, and we should get 600 revolutions per minute. So the larger gear is turning 600 revolutions per minute if the smaller gear is turning out 1400 revolutions per minute. Let's take a look at one more example. In our last example, it says the lottery prize is shared by 6 people. Each person receives $20,000. If it were to be shared by 4 people, how much would each receive? So you ask yourself the question, if there's fewer people sharing that prize, will each person get more or less money? The answer is they're going to get more. So it's an inverse proportion. We set it up as a product. So 6 people get $20,000 each. And that would actually give us our total prize. We want to know if we have 4 people, how much each would receive. So 6 times 20,000 equals 4 times X. And when we solve it, we're going to have 6 times 20,000 divided by 4. The answer will be 30,000. So each winner would receive $30,000. There are many applications of both direct and inverse proportion. And when you read questions, they're not going to say, this is directly proportional to this, or this is inversely proportional to this. You're going to have to decide that. And that comes through life experience. That comes from practice with these and understanding the concept of what a direct proportion is and what an inverse proportion is. So to summarize, if you have 2 quantities and if the relationship between the 2 quantities is they both behave the same way, so as one doubles, the other one will double, or as one is halved, the other one is halved, then you know it's a direct proportion and you set it up as division. Think direct division. So the ratios will be equal to each other, or the quotients will be equal to each other. If, on the other hand, you have 2 quantities and they do the opposite, so if one is doubled, the other is halved, that's an inverse proportion. And the way you set up an inverse proportion is you multiply. The products will equal each other. Make sure your units are consistent and in the same order, and then when you solve, you should get the correct answer. So practice both so that you're able to answer direct and inverse proportion questions that you're given in your math class, but also practice both so that you're able to use direct and inverse proportion in your personal life.